Section 2.4 is going to encounter what happens when we try to multiply functions together or divide functions by one another and then take their derivatives. So the first thing that we're going to take a look at is we're going to take a look at what's called the product rule. So the product rule, the question we would like to ask ourselves is, does the derivative of the product equal the product of the derivatives? Okay, so the first side of this equation is the product inside with the derivative notation on the outside. So that is, multiply the functions together and then take the derivative. The right-hand side says, what if I take the derivatives of each of them individually and then I multiply? So we're going to consider whether or not this actually works by doing a concrete example to see if it works. So the example that we're going to take a look at is 4x to the 9th for f of x and x cubed for g of x. And so the first thing we'll do then is we will take 4x to the 9th times x cubed, and we're going to do that because it's inside the parentheses, and then take the derivative and see what happens. So what is 4x to the 9th times x cubed? You're trying to take a derivative. I want to multiply the pieces inside together first. 4x to the 9th times x cubed. Okay, is everybody okay with that step? Like order of operations, you do stuff inside of parentheses first. So the first piece that we're trying to do is simplify everything inside before I do a derivative. Now then, what is the derivative of 4x to the 12th? (48x to the 11th). And this really is the derivative of that because we have worked inside, out. Our question is, could we have taken the individual pieces' derivatives first and then multiplied? So in other words, gone the other order. Instead of multiplying and then doing a derivative, could we have done the derivatives of each of them and then multiplied? So we're going to try that. So if we take 4x to the 9th and we do the derivative, and we take x cubed and we do the derivative. So what's the derivative of 4x to the 9th? That's the one you tried to tell me before. 36x to the 8th. What's the derivative of x cubed? 3x squared. Now we're going to multiply 36x to the 8th times 3x squared. And what do we get? 108x to the 10th. Are they the same? No. The answer to the question up here is that no, this does not work. The order in which we do that changes the answer that we get. So it is not possible to take the individual pieces' derivatives and then simply multiply the results together. We have to have some other way to do that. The product rule actually looks like this. If I want the derivative of the entire product of something, I do take the individual derivatives. They're right here. Do you see that g prime of x and that f prime of x? But they don't get multiplied by each other. You take the original first function, and I do this backwards from the textbook because I really like the fact that I can do the first piece without actually doing any calculus. So whatever the first piece was, you simply write it down. And then you do the derivative of the second piece. And then you reverse. You do the derivative of the first piece that was written down, and then you write the original of the second piece. Now, the order of this one doesn't make any difference whatsoever. It's addition, it's multiplication. I can multiply interchangeably. I can add interchangeably. So the order in which you're doing this makes no difference. In other words, if I wanted to, I could write f prime times g of x plus f times g prime. Or I could write down f prime of x times g of x plus g prime of x times f of x. Because I can switch orders of multiplication, I can switch orders of addition, and it doesn't change the result of the answer. Okay, so you may write yours in a different order than I do, and that's fine. It doesn't hurt anything. All right, so let's actually use the rule and see what happens. All right, so this is an example of one that we could do by distributing, right? We could simplify this out, we could distribute, and it would be beautiful, it would be no problem. We could do it that way, just like we did back in the last section. We can also do it with the product rule. So I'm just going to give you an example of one that you could have done the other way, and now you have another option. So the way that I do this problem is I write the first piece down, because it allows me to always start the problem. That's why I like to do it that way. The second piece, though, now I need its derivative. What is the derivative of x squared minus 5? 2x, you betcha. And then the product rule says I'm supposed to add. When I add, I now take the derivative of the first piece, that is the derivative of x squared plus 3, which is what? It's 2x. And I multiply that by the original second function, x squared minus 5.
What happened? You got a bit lost at the 2x.
Okay.
The first one.
This one?
Yeah.
That's the derivative of this piece.
What happened to the 5?
What's the derivative of 5?
Constant, so 0.
0. That's why. And if it helps you to see it, I know we've moved really quickly since we're doing both of these lessons in the same day. Here's what's really happening here, Chancellor, is that it's 2x plus 0. And the same thing's true on this one. This is 2x plus 0. All right, we're going to simplify this. And in general, we'll simplify the results that we get on the product rule. They don't always simplify by multiplying everything out. We'll see that happen in some of our examples. But on this one, we actually can. I've got x squared plus 3 times 2x. I'm going to write it back the way it was so I can see the multiplication just cleaner. So I've got x squared times 2x, which is going to give me 2x cubed. So I'm just distributing these. And then I have the 3 times the 2x, which is going to give me 6x. And then over here I have the 2x times the x squared, which gives me 2x cubed. And I have the 2x times the negative 5, which is going to give me negative 10x. These can combine, right? So I have 4x cubed. And these can combine, so I have minus 4x. So the grand result of our work was 4x cubed minus 4x. Okay. Let's try one that's a little bit messier. It's messier just because I have a fractional exponent, the 3/2. So the product ends up having some fractional exponents in it. Now, it is good to notice that because it's given as a fractional exponent, my answer can be left with fractions in the exponents. I don't have to change them into square roots or anything. So that's a good thing to focus on. All right, so the first thing I'm going to do is take the derivative, is to rewrite the first piece. The next thing I'm going to do is I'm going to take the derivative of the second piece. So what's the derivative of x to the 4th minus 2? 4x cubed, exactly. Now I'm back working with the first piece. The first piece that's underlined in black, x to the 3/2 minus 4x. What's the derivative of that? 3/2 x to the 1/2. And then the derivative of negative 4x? Minus 4. Very good. The last thing I do then, and this is the part sometimes people will forget, is that we have to rewrite that second piece as it is. That's all the calculus in the problem. You have done every bit of calculus you have to do for the problem. And the calculus is not usually the problem. The problem usually comes with what happens next, which is algebra, the simplification. All right, the fun algebra to simplify. So we're going to take a look at the algebra then to simplify. So on this one, I've got to distribute. So 3x to the 3/2 times 4x cubed. Well, I'm going to get a 4, and I'm going to get an x. I had a power of 3/2, and I have a power of 3. So what happens when I take 3/2 plus 3? That is 9/2. Very good. It's just adding exponents. All right, the other piece then is negative 4x times 4x cubed. So that's going to give me negative 16x to the 4th. Good. That was the easier of the two pieces because I had a monomial, 4x cubed, times a binomial. The problem with the other one is that I have a binomial, 2 terms by another 2 terms, so I have to FOIL is probably the acronym you're remembering. So we've got the first terms. So I have 3/2 x to the 1/2 times x to the 4th. So that's going to give me 3/2 x to what?
Squared.
Well, I've got a 1/2 and I've got a power of 4, and I need to add them, not multiply. Yeah, we add the exponents for properties of exponents. What do I get? 9/2 again. Yeah. 9/2 like I had before. So that's my first term. Outside, I have 3/2 x to the 1/2 times 2. Times negative 2, excuse me. What's that going to give me?
Quick question.
Mm-hmm.
How did you get 3/4?
Oh, it was, a typo. Does that look better?
Yes.
Thank you. Yes, it looks better to me too. 3/2. All right, 3/2 x to the 1/2 times negative 2. What's that going to give me? I'll start. Negative. Negative what? 3. X to the 1/2. Very good. Thank you, Noah. All right, that's my outside terms. Now I have my inside terms. Negative 4 times x to the 4th. Oh, I like that one. What's that one? Negative 4x to the 4th. That one's a good one. And our last terms, plus 8. How nice. We ended it simply. Some of this can combine. What combines?
X to the 4th.
The x to the 4ths combine. So, and that's actually the second thing that combines. Can we combine the 9/2 first? Yeah. Whoops, I underlined the wrong one. 9/2. All right, so I have 4x to the 9/2 minus, plus 3/2 x to the 9/2. So what is 4 plus 3/2? 11/2 x to the 9/2. And then we'll do that ones that I underlined in purple. I have negative 16x to the 4th and negative 4x to the 4th, which gives me, good, negative 20x to the 4th. Very nice. And then what? Minus 3x to the 1/2 and plus 8. So after we did the distribution, the collecting like terms was actually pretty clean. Okay, any questions on that one? All right.